I'm Andre Henry. I'm a 2018 Victorian scholar. Here to chat to you guys today about potentially using not just our processing tomato crop residues, but if you're in an industry that you also have waste biomass post-harvest. Firstly, I'd like to say a massive thank you to my sponsors. The Australian Processing Tomato Growers is a very small group. There's only 10 private growers left in Australia, so it's a small and innovative table in a small room at this point in time, as well as the alumni of Nuffield Australia. It's an enormous honour to be awarded a scholarship in the honour of Max Gelbart, and had been lucky enough to speak via Facebook with George and meet Tim and George earlier when I was awarded, and I can only hope that my learnings and the experience and wonderful opportunity that I've been awarded to zoom out on our farm business can have a similar impact within our family and our industry to what Max has had within his own industry and Nuffield more broadly. So a massive thank you to the Gelbart family, Nuffield Australia, as well as the processing tomato growers. A massive thanks also to my family. I think every Nuffield scholar that stood behind this lectern at some point in time has had the massive realisation that it's awarded as an individual award, but really the true thanks lies with each of you as a family member that stood behind the scholar and covered up for any mistakes that they made. So for my mum Rowena, my father Tony, my brother Jace, they covered for not just packing pasta sauce on pallets at 4 in the morning, getting everything done on farm, as well as completing off-farm work and full-time jobs as well. So I can never thank them enough for the opportunity to really zoom out and get a global perspective on what we do as a family, but also where we fit it within the world. So as Dave briefly mentioned, we're processing tomato growers in northwest Victoria. So on the irrigation system, we grow between 4,000 and 5,000 tonnes of tomatoes a year, split usually fairly evenly between SPC and Kagome as the major manufacturers. So going to the Ardmona cans you'd see on your supermarket shelf, or into paste for Mars, Dolmio, Legos, all that sort of stuff. I returned to the farm business in 2013 to try and vertically integrate our farm. So developed a range of probably controversial vegan jerky, pasta sauce and pasta. So for the beef lovers in the room, the vegan jerky is a fruit leather, a savoury fruit leather, but a fruit leather's worth 20 cents on the shelf, whereas a vegan jerky I can sell for $4.50. So that's my role as a tomato grower. So our challenge as an industry is probably broader than just me trying to vertically integrate with a niche product. So I see that as hopefully a way we can continue to add value to our own farm business. But I think I'd say the tomato industry is maybe a canary in the coal mine for where the dairy industry is going now. We've been massively hammered by subsidised imported product here in Australia. So Italian production's 50 to 100% lower than our average yields. We're paid 25 to 30% less per tonne, and yet probably when you go into a supermarket shelf, a Ladoria tin of tomatoes is still going to be 30 or 40 cents less than an Australian tin. So there's some questions to be asked around the supply chains of that, and what would you say, slave camps, labour issues, all of those sorts of things overseas that are brought up, and we're meeting everything with fresh care standards and paying the award wage. So it's becoming a challenging thing for an industry that is basically being paid the same price for fruit since 1986 to continue to be here. I think is a feather in the cap for the 10 growers that remain. So what did I see as an opportunity? I got an email basically about Nuffield probably 2 years before I applied from Jim Gelch. So it was actually to my mum and dad to come over for a day at Rutherglen and attend a day out with Nuffield Scholars, and it was a really eye-opening experience for me. Is seeing, I think you find in agriculture a lot of people will downplay their successes but also downplay their losses, and taking ownership of the mistakes you've made within your own business or the learnings that you've made and the jumps you've made. It actually created a really honest dialogue. So I walked away with my mind buzzing, to be honest, but I walked away wanting to find what was the opportunity and where could I add value as to what project could I really create for our industry. In processing tomatoes, we use subsurface drip. 100% of the industry is subsurface drip. It's hugely water efficient, but basically to cover the cost of the infrastructure installation, 4 years of continuous cropping back to back on the same paddock. So most growers are removing the biomass above the surface because it presents a disease risk. There's also been testing done that the tomato plant, because we're a large deep-rooted plant, we're removing salinity from the soil as well. So it's actually good to get the above ground biomass off the paddock. And there's been sort of questioning around whether removing the biomass is good for our organic content and our carbon levels in our soils, and they're actually steady state or increasing over a 4-year cycle. So I saw this as sort of a waste fibrous material that is not suitable for livestock, but it's highly fibrous, and we've left it in the paddock for 2 or 3 years and it doesn't break down. So at the moment, most growers are burning it, and I got calorific testing done on it. It's 14.8 gigajoules per tonne for every tonne that we're burning. You sort of think, well, what's that as a unit rate, basically? But to put it in terms, so I explained it to my dad, for every tonne of vine we're burning, we're throwing away 420 litres of diesel. So if you think about the energy usage of your farm, or what your major inputs are on farm, for us, energy is a big part of that. So where did my journey take me? I visited across Europe as well as the US a couple of times. I can't thank enough the researchers, the manufacturers, the farmers, everyone that I visited. It was amazing to find German patent specs online for a system and then go and visit his boilermaker, and you sort of get really excited about his technology, and then he'd sort of quietly say, you realise I'm having to translate what you're saying, and would be apologising for his English. It's astonishing where this tie will get you and who will open their door for you and the generosity that they'll have. So massive thank you to everyone that took me in. Originally I was looking at materials, so I sort of came to it as energy is a lower value use for it effectively. So I thought it's a fibrous material. If we can make a high value product out of it, vertically integrate in that way, it'd be great. There was a company in the Netherlands I was really excited to see, Solidus Solutions. They're making cardboard packaging boxes and stuff with tomato vine. I tried to go through Wageningen in a university, the production manager at Solidus, and basically was met with a brick wall that they were not available for comment on the product and it was no longer being commercialised. I visited Johnny Garzis at Cornboard, so I drove up into the panhandle of Texas, and they're making some really interesting fibre press boards. So they're using the leaf matter off corn stalks. They've been quite smart how they did the business. They're creating boards for a building material purpose, but have created sort of hero products. So they have skateboards, snow skis, surfboards, everything within that market to sort of drive that consumer awareness of their product with the intent that it'll be a large-scale commercial product later. Unfortunately, it became pretty clear pretty quickly. Johnny was describing, like when I described the vine sort of structure as a plant, because it's a tube, a hollow tube, the tomato vine, we can't really compress it in his system, so they're sort of compressing it at 300 psi and injecting formaldehyde to make hard glued sheets. And his indication was that that's why they trommel screen off the corn cobs and the stalk, because they need the flatness of the leaf so you can actually create a stable board. So it probably summed up seeing him work the factory as well, is it's very difficult to produce a consistent product from an inconsistent feedstock, and that's probably been the issue I think with a lot of biomass and crop residue waste in the past, is that we don't know a lot of the time what's in it. It can be a bit of a mixed bag. So I looked at energy. There's a world of alternatives out there. It's a bit like agriculture. Everyone thinks they're doing it the best way, and maybe they are for the system that they're within. Biogas fermenting, I probably should say my thoughts around it were it needed to be something that we could apply on farm or as an industry group, so pulling together as growers. Biogas fermenting I sort of ruled out, where we've basically got a waste biomass product, but we don't have manure and the other things to create a system that could utilise that. Direct combustion in straw boilers, that sort of thing for heat. We don't really have a heat demand. Because we're processing fruit, we don't even have a cooling demand, so we can't run it through a heat pump, so didn't really have a use there. Looking at steam turbines and steam boilers, there's an enormous amount of pressure arrays because you're creating high pressure steam and supersaturated steam to do that. Things like Stirling engines to create work over a cylinder because you've got a heat differential. Again, all of these things, it was an interesting space. Biomass energy has been a massive investment in renewables throughout Europe, but similar to agriculture, it became quite frustrating as a lot of the research direction has been driven by subsidisation. So when we refer to biomass, we consider it to encompass all of biomass, whereas really when they're describing biomass, they're talking about wood chip. So I looked at gasification systems and pellet boilers and things that they were all tied in, but all of them were basically building their system around wood chip. So organic Rankine cycles for lower value waste heat, so it's the same principle as a steam turbine, but basically instead of using water as the working fluid, you're having something with a boiling point below 100 degrees. So you can use a lower value heat. So this is probably the best way that I sort of ended up drawing it as a problem for myself in the back block of a hostel in Austria. Actually, is it became clear that there was solutions such as the VIP one I mentioned on the previous slide, the little green one in the corner, a steam engine a guy in Vermont had developed for use in India, and now a $20,000 system for a 10 kilowatt system, which is closer to where we could be commercially relevant. The problem is it's only 6% thermally efficient. So some of the micro turbines that I was seeing in the Netherlands might have been 40% efficient, which is astonishing in steam engines. The problem is you're talking about a €40,000 investment just for the turbine, and then you've got to create the steam to do it. So I ended up in this situation where you had the capital cost, the practical application of what would actually fit within our system within Australia, and also the efficiency, and finding something within that became very, very difficult. I actually visited a professor in the University of Acton in Birmingham, and he flat out just looked me in the face and said, there is no technology that will fit the problem you're describing anywhere in Europe, which is quite hard when you're sort of halfway through your trip. So I arrived at, I think we could combine alternatives. So gasification effectively is cooking waste biomass in a low oxygen environment where you're controlling the air. So you're cooking something at 700 degrees to release the volatile gases. So you can control that temperature and air entrainment to maximise what your methane yield or CH4 yield is off it. So you end up with a gas stream and then a carbon char stream. So some people have used that as a soil mirror, but I'm sort of looking at the energy side of it. And the other one was hydrogen and ammonia production. So if we can produce methane from this stuff, is that a big component of CH4 is H2. So it probably answered the two questions for me. Is each time there was an energy conversion when you're trying to make Vine into heat or Vine into work or Vine into electrical energy, every time you have a conversion you have an energy loss, so you need to make up for that somewhere. So ammonia to me fitted the bill, is that by creating the conversions we're also creating a conversion in the value of it at the end. So how could something like this work? I looked at it is that potentially we could look at baling the vine, gasifying it to produce our methane stream. There might be industries within this room that already have an existing methane stream. We can use a steam methane reformer. So some of this technology is actually quite old. It's been around since World War I. Use a steam methane reformer, which is basically cooking methane in a high moisture content with H2O to produce CO2 and a split hydrogen stream. And then use a pressure swing absorption generator. So where our family used to farm fish as well. So you can basically filter the nitrogen and oxygen components from air, and nitrogen's actually an easier one with the air sieves to manage. So once you've got pure streams of hydrogen and nitrogen, you can combine them using a Haber-Bosch process to produce ammonia and basically pressurise it in a tank. So there's a couple of, I would call them pioneers in this space. I visited the University of Minnesota and Mike Reese and his team, and it's quite amazing where they've got to in terms of using electrical energy to generate the hydrogen component. So hydrogen is the biggest cost to producing ammonia. It's the most energy intensive part of the process. So they're using a 1.2 megawatt windmill on their university campus to produce ammonia on site. They're sort of more of a demonstration scale as to where the technology could be. So electrolysis, they're splitting the water using electrical current and then combining it with nitrogen from their pressure swing absorption within a Haber-Bosch. So they're probably creating the data and the extension around people that can step into it in the future. And what got me really excited was visiting Jay Schmuker's farm in Iowa. He's a retired bloke from NASA, and he wanted to create a project to honour his father. And using hydrogen was the initial idea, and I think ammonia should be sort of seen as that next step. There's a lot of talk about government incentives and growth within hydrogen as an energy source these days, but ammonia is kind of that next step. Like he's converted a 7810 John Deere tractor, but to put it in perspective, the ammonia tank's only the little one at the front, and it contains twice the embodied energy of the four behind it, and it's at half the pressure. So it's sort of, when we're talking about hydrogen production, all that sort of stuff, everyone has got excited about that and then moved on to the next thing when really they probably were halfway to a really good idea. So there's a lot of electric vehicles and renewable technology in that space, but there's not really anyone talking in heavy vehicles and this space, and that's working now. So he's got an 8 kilowatt solar array generating fuel for his tractor, and then he's using the rest in fertiliser. So my recommendation was I went back to Proton Ventures in the Netherlands. They're actually making turnkey systems for this stuff now. So there's a lot of stranded shale and gas deposits in North America. So they need to find ways to monetize small-scale deposits that it doesn't make sense to connect with a pipeline. So these guys make systems from 1,000 tonne up to 20,000 tonne a year. So an Nuffield one would be more than big enough for our industry. I'm looking at our industry's overall figures. We're probably using 400 to 600 tonne of nitrogen per year. So we'd have beyond that, but we're sort of talking about a potential of investment where we're spending $1.2 million roughly as an industry on nitrogen fertiliser. A system like this is 5 or 6 million, so it's a big bit of the wallet. But you can also use, we've got a 30,000 tonne resource of vine there, so there's the potential to produce 6,000 tonne of ammonia if we wished, which would represent a 30% increase to our industry's revenue. That's not attached to fruit, it's not attached to subsidisation within our primary markets. So even a small scale system, if we were using 400 of the 600 tonnes and putting the rest into our local area within ammonia production, like, we're really well set up for this. Like, we already fertigate. Most tomato industry fertilisation is occurring via subsurface drip with UAN anyway, so we're literally just changing tanks. And the exciting thing, the University of Minnesota guys, despite going way down the path with Jay and completely retrofitting a tractor, these guys can make manifolds, and ammonia can be used to replace diesel at a 50% ratio anyway. And again, it sort of suits what our industry is it works best when the engine is running at load and all of our pumps are running at load. So it's sort of starting to line up in my eyes as to what we could potentially do. So future work, I came back and had a visit with the ANU because there's a lot of knowledge in this space around gasification, a lot of knowledge in ammonia production, but linking the two, I think probably I've been the first one to be silly enough to try and see the need. But we need to probably define where our research goals are in how much hydrogen can we produce per dry tonne of tomato vine biomass, and then look at our potential to secure ARENA and ARC funding. So even a cursory glance as the energy content to produce our fertiliser, if we can produce our own, we're saving 1,500 tonnes of carbon emissions a year. So there's a lot of government money being spent in this space to try and help industry transition in that space. So if the testing and that sort of stuff comes back, build a business case and a business structure that growers can invest into if they wish, or our suppliers within our own industry, and secure investment. So my concluding thought to you as a room is, whatever sector you're in, is there an aspect of your business where you have a waste stream that is not being monetised and does not have a market, but is there a way you can internalise it to reduce your internal costs? So thanks for your time, guys.